This video is on power models. We're going to be using the three ways to the patterns of the graphs to be able to graph sketches of these equations. We need to first determine if it's a direct or inverse variation, because that will tell us if it's going to go through 0, 0, or if it's going to have asymptotes. We need to determine if it's positive or negative, so we know if our graph will start in quadrant 1 or quadrant 4. Then we also need to determine if it's an even or odd exponent, because that will tell us the second half of our graph will either be side by side or it will be opposite or diagonal quadrants. So this first example, we go through and list out everything we know. So first thing is direct or inverse. This is a multiplication, your x is on top, so this is a direct variation, which means that it will go through 0, 0. So we can go ahead and put a coordinate through 0, 0. The next part is if it's positive or negative. So our k value is 2. So our k is bigger than 0. That's positive, therefore that means we're going to go through quadrant 1. So we're not going to have quadrant 1 over in here. Then we need to know if we have an even or odd exponent. Now this one, we actually have an exponent of 1. That is an odd exponent. It's an odd exponent. That means it will also go through opposite quadrants. So that means it'll go through quadrant 4. Because we had, I'm sorry, not quadrant 4, quadrant 3. Because we have quadrant 1 already. So the opposite of quadrant 1 is quadrant 3. We also need to know if it's going to be more steep or if it's further away from the origin. So because this is a direct variation and the value is bigger than 1, the graph is going to be more steep. So it's going to go quicker through quadrant 1 and through quadrant 3. Now the thing about this is a basic direct variation. This is not a power model because this is an exponent of 1. What that tells us, since this is a basic direct variation, there is actually no curve. There is going to be no curve at all. This is just going to be a line that goes through quadrant 1 and quadrant 4. Quadrant 1 and quadrant 3, I apologize. And it will be more steep than just a regular line that goes a slope of 1. So it will actually be more steep. So quadrant 1 to 0, 0, and then goes to quadrant 3. So this would be a sketch of our graph. For number 2, again, we go through the three things. This is a direct variation. That means it does need to go through 0, 0. It's a direct variation because this is a multiplication of x. We have our k value is 2. It is positive, so it's greater than 0. That means we will go through quadrant 1. Then we look at our exponent. We have an even exponent. That tells us side by side. So in this case, side by side to quadrant 1 would be quadrant 2. So we do know we're going to go from quadrant 1 into quadrant 2. Because we do not have an exponent of 1, we will have a curve. It will curve from the first quadrant to 0, 0. We do know it has to go through 0, 0. It will curve, and it is a value of 2, so it is more steep. So it's not just going to be a line. It will curve away from 0, 0. There's our first half. And then the other half has to go quadrant 2. So we're going to take from 0, 0 and curve it away. So this is a parabola. And if we recognize this function, this is y equals 2x squared, which is the equation of a parabola. This is a quadratic. So this actually makes a lot of sense of why this happens. On this next problem, we again have a direct variation because this is 2 times. So that means that it will go through 0, 0. Then we look to see if it's positive or negative. We have a value of 2, so k is greater than 0. That means it will go through quadrant 1. Then we look at our exponent. Our exponent is 3, which is odd, which tells us we have opposite quadrants, which in this case from quadrant 1, opposite of quadrant 1 is quadrant 3. So we know that we're going to have 0, 0. It does have an exponent that's not 1, so it will curve. So the only one that does not have a curve is when it is a basic direct variation, a linear equation, which is direct variation with exponent of 1. This is the only one that does not have a curve. Everything else will have a curve. Our k value is 2, so it is, because it's direct variation, it will be more steep. So we are going to curve it from 0, 0. We're going to curve it away. It has to go through quadrant 1. Then it also has to do the same thing in quadrant 3. So from 0, 0, and it has to go into quadrant 3, and it has to curve. So this is the basic shape of this equation, y equals 2x cubed. On example 4, same information. So we have, this is a direct variation. So it does go through 0, 0. Our k value this time is negative, so it is less than 0. That means it has to go through quadrant 4. Then we look at our exponent is 3, so that's an odd, which means we're going to have opposite quadrants. So the opposite of quadrant 4 would be quadrant 2. So we can go ahead and put a 0, 0. It will curve. So it has to curve into quadrant 4. And again, it has a 2. The value is just 2. So that means it's going to be more steep. So we have the quadrant 4. Then we also have to do the quadrant 2. So we start at 0, 0 again. And it has to curve into quadrant 2 at about the same amount. This is the basic shape of y equals negative 2x cubed.